In this part of the algebra series, we are going to be taking a look at factorizing equations. We are going to be starting off with the factorizing basics and then moving on to the difference of two squares. So what factorization is essentially just adding brackets into the equation, which is the opposite of multiplying brackets out, the topic that we looked at in the previous lesson. So how do we do this? First, we start off with taking out the largest common factor that goes into all of the terms. So here 7 goes into both of these coefficients. X squared is the maximum that will go into these two here. So that becomes our number here. Then we add an open bracket and we write in the numbers that multiply with this common factor to give us the original equation. So 7x squared times 2 gives us 14x squared. And 7x squared multiplied by x gives us 7x cubed. And just as a check, just as we done right now, just simply multiply out the brackets and we should get this original equation. So 14x squared plus 7x to the power of 3. Nice and simple. Okay, moving on now to some practice questions. Here we've got 3x squared plus 9 and we need to factorize this. So first we need to take out the common factor that goes into both terms. We know that 3 goes into both 3x squared and 9. There is no x here, so this is just going to be our common factor. Now open bracket. To get this term here, we need to multiply 3 with x squared. And to get 9, we multiply 3 with 3. That's our final answer. So here we have more letters to deal with, so let's break this down one by one, starting with the coefficient. So the largest number that goes into both 4 and 16 is 4. The maximum value that goes into x squared and x cubed is x squared. And the maximum value that goes into y and y squared is just going to be y. Okay, so now we add in our open bracket. So what do we need to multiply 4x squared y to get this here? 4x squared y just itself, so this is going to be 1. It's a minus sign. We're going to multiply 4 by 4 to give us 16. X squared by x to give us x cubed. And y with y to give us y squared. Now again, as a quick check, just to make sure we've got it right, we can multiply out this bracket and we should get this original equation here. Even when we do this in our heads, it's just good to write it down to make sure everything is correct. Yep, all good. Okay, moving on to the last one. Again, as we did before, let's break this down. So the largest number that goes into 7 and 28, 7. C to the power of 4 and c is going to be just c. P and p squared, again, just p. Open bracket. So to get from 7cp to 7c4p, the only thing that needs to change is this c. The 7 and the p are going to stay the same. So we're just going to write c to the power of 3, so minus 7 times 4 gives us 28. C times by itself to give C, so we don't need to add anything. P multiplied by P to give us P squared. Now the same thing, if we just multiply it out on our working. And that's correct. Moving on now to some more practice questions. If you could please pause the video here and have a go at these yourself, and resume the video and we'll go through them together. Okay, so let's look at the first one. Starting off, we need to find the largest common factor. So the largest number that goes into both 12 and 18 is 6. The maximum value that goes into x squared and x is x. And the maximum value that goes into y and y squared is y. Open brackets. We multiply 6 with 2 to give us 12. We multiply x with x to give us x squared. And there is only one y, so we don't need to add anything. It's a minus sign. We need to multiply 6 with 3 to give us 18. Multiply x with just 1 because there's only one x here. And y multiplied by y itself to give us y squared. Second one. So the largest number that goes into 15, 20, and 5 is 5. A to the power of 3, a to the power of 2, just a. It's going to be a. B squared, b, just b. So we're going to multiply 5 with 3 to give us 15, a with a squared to give us a to the power of 3. B is on its own, so we don't need to add anything. 5 with 4, a with a, and b with b. 5 with just 1, a with a, b with b, so this is going to be just 1 to give us this here. Third question, the largest number that goes into all of these coefficients is 9. And x isn't part of all of these terms here, so we can't include it as the common factor. So we're just going to have 9 on the outside. 9 multiplied by minus x. 9 multiplied by 3x gives us plus 27x. And 9 multiplied by minus 2 gives us minus 18. For the final one, 9 is the largest number that goes into 18 and 27. And we've got x in this term and in this term, so we can include that. Y isn't part of this term, so we can't include it in the common factor. So 9 times 2 gives us 18. X times x gives us x squared. Minus 9 times 3 to give us 27. There's only one x, and we're going to add a y here. Okay, so these are the final answers for all of these questions. Okay, moving on now, we are going to look at the difference of two squares, simplified to dots. Now, all this is simply just an equation where we have one term squared, here a squared, minus, has to always be a minus, another term squared, so b squared. And the way we factorize this is not by single brackets, it's actually double brackets. And then we have first term plus the second term, first term minus the second term. So let's look at an example here and see why this works. And just a quick pointer here, the numbers included in this equation have to be square numbers. Otherwise, this way won't work. So let's look at this first example. We have y squared, our first term, minus 9, our second term. So if we rewrite this to make it look like this, that gives us y squared minus 3 squared. Now, if we want to factorize this, we write out double brackets. First term plus the second term. Can be a plus or minus here, either way, it doesn't matter. And in the second bracket, we're going to have the first term minus the second term. Now, let's see why this actually works. If we multiply out, That gives us y squared minus 3y plus 3y minus 9. Now if we simplify, minus 3y plus 3y is 0. They cancel each other out. So we're left with just y squared minus 9. Okay, one thing about these questions is that when you're given this question in an exam, they are not going to say that this is the difference of two squares. It will simply just say factorize. So we need to spot ourselves that an equation needs to be solved by the difference of two squares. And we do that by seeing if we have two square numbers here, two square terms, and there's a minus here. It has to be a minus, it can't be a plus. Okay, so let's work on the second question now. So if we rewrite this, we've got p squared minus the square root of this, so 4q squared. Now we're ready to factorize. P plus minus 4q. Again, as a check, let's multiply out. P squared minus 4pq plus 4pq minus 16q squared. Minus and a plus cancel out, and we're left with p squared minus 16q squared. Okay, moving on now to some more practice questions. If you'd like to pause the video here and attempt these 4 questions, we will go over them together once you're done. Okay, so the first question, we need to have double brackets, and we need to have the square root of each of these terms. So we're going to have 2a, square root of 25 is 5, 5b, we're going to have a plus and a minus. Now if we multiply out, 4a squared minus 10ab plus 10ab minus 25b squared, minus and a positive cancel out, and we're left with our original equation of 4a squared minus 25b squared. Okay, second one, the same thing. Double bracket, square root the numbers. So square root of 121 is 11. Square root of t squared is just t, and we're going to have just 1 on the other side. We're going to do plus and a minus. 121 t squared plus minus cancel out, minus 1. We're left with this. Third one. This one's a bit more easier. Plus and a minus. Square root of 121 is 11. And our last question here. Got 4y, 3x, 4y, 3x, plus and a minus, and there is our difference of two squares. Okay, so I hope you found that useful. We are going to be looking at quadratic factorization in the next video, so we'll go through a bit more complex questions. So I will see you in the next one.